Good morning, all. Today we have with us Dr. Debanjan Das. He will be speaking on AIoT in smart agriculture, higher yields, better quality, and increased efficiency. Let me take honor to introduce our today's esteemed speaker, Dr. Debanjan Das. Dr. Das is an assistant professor in electronics and communication engineering discipline of IIIT Naya Raipur, Chhattisgarh. He has completed his MTech and PhD from Department of Electrical Engineering, IIT Kharagpur, in the area of sensor and instrumentation. Currently, he is the faculty in charge of IoT and Sensors Lab in IIIT Naya Raipur. Dr. Das has more than 9 years of research and development experience in the sensors and instrumentation, signal processing, etc. He has filed 6 Indian patents with 1 granted. Currently, he is investing to multi-crores funded projects from ITs and NMICPS, Government of India. He has published about 60 plus research papers in international journals and conferences, including prestigious publication in Nature and IEEE. Nature IEEE. Currently, his main research interests include IoT and smart sensing, signal processing, and predictive maintenance. He is a senior member of IEEE and IEEE Instrumentation and Measurement Society. So thank you, Dr. Das, for agreeing to be with us and share your valuable experience on artificial intelligence related areas in agriculture IoT uh, or some sort of that in AIoT.
Right,
Sir, I request you to start, sir.
right. Okay, so thank you for your nice introduction. So let me go back to my presentation. Right. Uh, so as the title says, it's AIoT in smart agricultures. Okay, and bottom line is that we want to achieve higher yield, better quality, and increased efficiency. So what my presentation outline that will follow, that will introduce what is this AIoT. Okay, because all of us having some idea about the what is AI, what is IoT. Maybe in this FDP also you have learned about the IoT. Okay, but I'll talk little bit different things, or maybe the mixed up of these, which is nowadays becoming more and more popular. AIoT. Okay, so we'll see what is that and why it is becoming more popular, right? Then what are the different technology enablers for this AIoT and different application specifically. Then after that, I'll come to the agriculture point of view. Okay, there I'll discuss that whatever the work that we are working in our group using this AIoT technology to solve some certain agriculture problems. And so that will cover under these smart agriculture specific examples. Then uh, I'll discuss what are the research challenges, because I do understand there is a lots of maybe there is some the research scholars or the means faculties also obviously is theirs, but along with maybe there are certain research scholars are also attending, right? So they can look into what are the different challenges specifically with respect to IoT. So along with the future direction. So with this the my entire talk I have arranged. Okay, so now let first let's see. Okay, so all of you have probably heard about the IoT by now. Okay, or even maybe you got in this FTP some basic idea about the IoT. But but the question comes: have you heard about the term AIoT? Okay, so what is that and why it is now a trend? Okay, so the question comes: why AI and IoT is blended and whose form they are blending, right? And what is this IoT? Okay, and why it is matters, right? So these we need to understand, right? So if we start with the basic of IoT, okay, so we know these are very basic definitions that you can find in Wikipedia, right? What it says, IoT describes a network of physical object, and that we are calling as a thing, which is nothing but a some embedded with sensors, okay, which is having the processing abilities, having some softwares and other technology, okay, so all together is we are bringing, and at the end, we are going to connect and exchange data with other devices and system over the internet or either communication networks, right? So that is the IoT. Okay, so if we split the IoT, so then what is coming? So it is nothing but the connecting various things to the internet, right? And so what do you mean by the things? So there is a clear distinction between the things and devices which is made or originally manufactured to connect to the internet, right? So the things definition, it says the object which is not originally manufactured to connect to the internet, the moment you're connecting that object to the internet, so then that object becomes as a thing. For example, l- uh, uh, take lot means all of us is sitting on chairs, right? This chairs is not made originally to connect to the internet, but with the vision of IoT, now we are able to connect that chairs to the internet. In which forms? Maybe we want to see that what is our occupancy, okay, what is our postures, orientations, right? Mm, so many other activities we can recognize, right? So for that we are connecting some means we are connecting these chairs, right? And then we are making a network, right? So with this respect, we can say that your chairs under vision of the IoT will become as a thing. Okay, so how it will be done? So that means you can understand you have to sense and you have to communicate, right? So sense means means on that chairs you are putting some kind of sensing mechanisms, right? And that information you're communicating through the internet, right? So that is the basics of the any of the internet or IoT technology, right? So what is the goal of this IoT? Okay, so majorly you can see there is a we have a total four goals. Okay, so the first is your data collections, right? So where using different sensors, okay, we track the state or the features of the physical things. Okay, so the data collection is the first the goal or the objective we can say, and there we are doing different kind of again studies like your data accuracy, time criticality, energy demands, privacy concern, right? So there is again different research the orientations is there, right? What people are addressing. Next, the data transmission. So in data transmissions, you have the again different kind of technology we have, right? So like your Bluetooth, your Wi-Fi, RFID, 5G, right? So different new technology also like the 6G, 5G, those also coming into the pictures, right? Um, so now based on a requirement, okay, where you are going to apply or where you are going to deploy your IoT solution, right? Based on that, we have to select the data transmission or the data communication technology. Next is a data pre-processing, okay, or data processing that I can say, because you try to understand through IoT, are collecting the data, but at the end we need some meaningful information from this. Okay, so that means the data processing is also part of that, right? And then at the end you're delivering some meaningful information or the solutions, right? So these are the all four. You can say the broadly we can define that the goal of the IoT. Okay, so one important things you can see there's a data processing is already there in part of the IoT, right? So when you come to the data processings, so there is comes that AI, right? So now what is the goal of the AI? So again, the goal of the AI you can differentiate in the four categories. The first is the perceptions, okay, which is nothing but the it's bridge the gap between the intelligence system and the real world systems. Okay, so here again you obtain the various sensor data, right? And you process the data, and from this you build up your interpretations, right? So under perceptions, right? Next is your learning. So now based on the collected data, right, you're making your system automated. Okay, you're making your systems to work or take decisions automatically. Okay, so for that you have a different learning mechanism. Maybe there we can say a different machine learning mechanisms is theirs, like a supervised, unsupervised, different learning process is theirs. Next, means goal of the AI is that we want to uh, build up the reasoning process. Okay, means we want to extract certain rules okay, and the derivative logical conclusions from that. Okay, so again, we can see that if there is any trend, whether the trend is monotonic or non-monotonic, right? So all those analysis we can do it, okay, or we want to do it, okay. So under this reasoning process, and at the end, the behavioral the analysis, right? So which is not only limited within the computer science, okay, so it is beyond that, okay, means it may be biology, it may be social science, it may be agriculture sector, right? So that's the another of the goal, right? So that means you can understand there is a certain goal of the IoT, certain goal of the AI. Okay, so now if we mixed both the things, right, so then we can see that there we can achieve the advantage from both of them, right? So that is the overall idea, right? So now if you see the traditional IoT architectures, so in traditional IoT architectures, what we have a perception layer, means if I consider the three-layer basic architectures, right? So you have a perception layer, you have a network layer, you have application layers. Okay, so this is in traditional you have it, right? So now that things in a very simplified way, if you now look into what you will have in your perception layer, which is nothing but you have your the object or the thing, right? And your sensors, node, everything that you have, right? So that is nothing but your thing. And then you may have a multiple things or multiple sensor node that they are connected in a gateway, right? And then the data which is sensed by the things pass through gateway to the cloud, right? And on the cloud, you're doing your data analytics or the data analysis. And then the what is a meaningful things, meaningful information, or what is a action to be taken based on your collected data, right? So that you're intimating through the user interface, right? So now, so this is the traditional process, right? So now the point that you try to understand that as I mentioned, the data processing or the analysis is also part of my AI. So now currently in traditional IoT, while we are doing this data analysis, we are doing data analysis on my cloud, right? But now it is coming that can I take these decisions or can I take my this data analysis part? Okay, not only the cloud, can I bring towards my thing? Okay, so that means if I can bring my these analytics parts instead of cloud to the things, so then what I'm doing, I'm not only making my thing to collect the data, also take the decision then and there itself. Okay, so that means I'm making my thing intelligent. Okay, so with that it is coming the the term AIoT, okay, which is nothing but the artificial intelligence of things. Okay, because so far your thing is not intelligent. Your thing is only can sense and send the data, okay, but it does not have any kind of intelligent. But the moment you can bring that AI part on your thing, so then your thing is becoming intelligent. So so from the term it comes that AIoT. Okay, and this concept you can much more broader way you can visualize from these pictures. So this is an in any the robotic systems, okay, that can be industrial or agriculture, any applications, right? So what is under this IoT means vision, what we are doing, we're connecting our sensors, right? We're collecting the data through the sensors, then we're communicating through the our suitable communication mediums, okay. Then we are aggregating all this data, right? And on that aggregated data, you are doing your analysis, means you are applying your intelligence, right? And based on that intelligence, your end devices, okay, so that may be some actuators, that may be a robotic arm, right? So that he's doing some kind of actions. Okay, so that means you can understand that this act, okay, what your end device is doing, right? It depends on this analysis. This first point. Second things, if it is need to be automated and fully accurate, then what you need, there should be some feedback mechanism, right? Means what action is taken, whether it is correct, how much correct, right? So that also need to be send it as a feedback to your the analyzers, right, or the controllers, I can say, right? Or in this case, I can consider my the augmented reality intelligent, right? It should take that what is a action is taken, right? What is the action command is given and what is the action outcome, right? So whether there is a matching or not. Okay, so that means this is again, you can understand there is a closed path. Okay, and this closed path can be means you can say achieved by implementing this IoT and AI together, right? So that means if I make this analogy with respect to our human body, right? So that means you can understand that IoT is, we can consider is nothing but our digital nervous systems, and AI is our brain, right? So yeah, so if we at the end it comes that it should be in it should present in a simultaneously, okay, or in one place. If we can bring all those things, okay, so then there is a lots of advantage or lots of intelligent or smart solution we can develop. Okay, just like if I consider in our human body how everything's in a very intelligent way that we are doing, right? So that is our idea, right? So that means from this again you can I am summarizing what is this IoT. Okay, so IoT, it enables devices to perform self-driven analytics. Okay, so that's the point I mentioned, that you bring your thing and think together at your end device end, means at your the physical layers where you have your the particular sensors or the particular object, right? And then you are making the EIoT based solutions. Okay, just a simple example you can understand. So like we have the traditional surveillance camera, right? So that say sends the data and send to the cloud, and at the cloud you take the suppose your face recognition and all those things. Okay, your data analytics you're doing at the cloud. Okay, but nowadays coming the AGI camera. Okay, so that means the intelligence is there in the camera itself. Okay, means you no need to further convey the data to the or totally rely on the cloud data analytics, right? So this is an example of the AIoT, right? So from this you can understand that with this the introduction of AIoT or with the vision of AIoT, right? What exactly now is coming more and more prominent, that the earlier we used to have only the cloud analytics. Okay, now it is coming more about the edge computings. Okay, so it's not only the cloud computing, edge computings. Okay, so the moment we're talking the edge computing, so then it's coming there is a lots of the other challenges. Okay, so that also we need to parallelly take it because you understand if doing the analytics or analysis at the cloud end is much easier, because we consider cloud having the unlimited source of energy, the resources, your space, okay, your GPU availability, everything that we consider means ideally the unlimited. Okay, so that means you can build your whatever the complex model you want, right? But that is not the situations or the means the scenario of if you are bringing the your AI to the edge, okay, or on the thing, because on edge of the things you have a limited your hardware resources, you have a limited energy, right? So you have a limited your CPU performance there, right? So you the model that you have at your cloud, right? The same model you can't deploy it. Okay, so there it's come that how we can do or what are the technological thing is coming, right? So that this AI part also I can bring on my thing is the first point, right? So this is the software point of view I can consider. Now hardware point of view it is coming, how I can make my hardware also much more efficient. Okay, means efficient in the sense the processing point of view. Okay, next it's coming that how I can make my the end device or that the edge device, right, more secure, because as I am doing my analysis there, right, so my device security is also parallelly coming, right? So this is the new the other option or the challenge means the opportunities coming along with this IoT, right? Now, if we see what are the benefit of this, okay, so if I can implement this IoT, okay, so then I can have the more means operational efficiency I can increase. Okay, because see now earlier if in traditional IoT system what is happening, you're sending all the data to your cloud and your decision you're taking at the cloud, right? So that means it is a if there is any delay sensitive operations, okay, so then you may lose your the efficiency, okay. So for those delay sensitive operations, if you are able to do your analysis at the edge itself, right, so then it is becoming much more efficient. Okay, hope you understood what I want to say. Okay, next you can do the increase the IoT scalability. Okay, better risk management, less unplanned downtime, right? New product and services means, and also the other advantages that I mentioned, the convergence of AI and IoT. Okay, these are the two different paradigm, right? So the moment they are converging, right? So then the lots of other advantage that we are going to get it, right? Now, as I mentioned, there is a challenges is there, right? You can't bring the same kind of your AI model to your edge devices. Okay, so on that context, there is a different new enabling technology came. Okay, for this making this AI interface at the edge, right? So designing the compact networks. Okay, so people are coming with a defined kind of means constructing different new deep neural network model. Okay, so we say in a compact size. Okay, like for example, you have a mobile net, exception net, squeeze net. So these are the from the name itself we can understand from the mobile net, right? It can be deployed at the mobile phone. Okay, because you can use your mobile phone as a sensor node. I'll justify why you can use your smartphone as a sensor node. Okay, in my subsequent slide. Okay. Next is coming the parameter pruning and the sharing. Okay, the it's come that what is the neural networks of total parameters, right? Can you do some kind of pruning? Means can you do the reducing? Okay, if there is any redundant parameters, can you discard it? Okay, so the overall my size will be reduced. And third one is the knowledge distillations. Okay, so again, it's come that the very large deep neural networks, okay, through these distillations process, you make it small. Okay, so that you can deploy your the neural networks model or the deep learning model at the your edge. Okay, but the point is that I should not compromise on my accuracy. Okay, that is the bottom line. Without compromising the accuracy too much, can I bring my deep learning model, okay, in a reduced form, in a small weight to my edge devices? So that is our idea, right? Along with the different other distributing techniques also coming. Okay, so in this context, like federated learning, the transfer learning, these are the concept is coming. Okay, see the federated learning, what is the overall concepts? So again, try to visualize in IoT context what you are doing. We have a defined sensor node. We are collecting the data. We are sending the data to my um, cloud, right? So now when you're sending your data to the cloud, right? So there is coming your data security, right? Next is in IoT context, another important is that your data, the privacy. Okay, so user don't want to reveal him or herself, right? So and there it's come that instead of sending the data to your cloud, can I make the arrangement that the model now I'll make available to my edge? Okay, and this one aspect. Second aspect, so then what will happen? You can reduce your data privacy and all those things. Okay, because you no need to send your data to the cloud. Okay, so that your entire networks site. Okay, what is the security issue that you can handle it? This first point. Second point, now you have a different sensor node, right? So it is coming that you have all the sensor node is not connected with the same variety of the environment or same environmental situations or not with the same instrument. So your data is much more heterogeneous. Okay, so the moment you are bringing your model to your one your edge, right? So on that particular edge, so your data is not that much heterogeneous. Okay, because if you are able to send your data to the cloud, so then you have a multiple data. So your data may be heterogeneous, your model will be much more robust. But that will not be situations if you are bringing your data to your edge. Okay, so there comes that, okay, so I have connected define sensor node. My model is there, but it will take the model. Means now model is available to all the sensor node. Now which sensor node is giving the best accurate model? So that model will shared to among all the sensor node. Okay, so that is the idea about this federated learning. Okay, so define new techniques is coming. Okay, under this vision of this edge computing or the AIoT. Okay. So now let's come to, so I hope you got a little bit of my brief idea about this, what is a IoT. Okay, so the bottom line is that, again, I want to emphasize, you're bringing your AI instead of doing on the cloud to your thing, which is nothing but at your edge devices. Okay, and so altogether, so you're making your thing much more smart. Okay, the moment you're bringing thing and thing together, you're making your sensors node, I can say, or the thing is smart. Okay, so with that visions, we can consider, yes, you are making a smart agriculture, smart healthcare. So all those domain is coming under that visions. Okay, so now let's see, let's concentrate our application area. Okay, our discussions for this smart agricultures. Okay, so now before that, let's try to understand what is the Indian agriculture scenario. Okay, because from this we can understand what are the challenges. Okay, so you can understand the 67% our population is rural dependent. Okay, and majority of them is agriculture dependent. Okay, so that means you can understand the scope and the volume of these applications. Okay, and the also you can from the GDP point of view, 50% of the GDP, okay, it comes from the agriculture. But what are the problems? That majority of our the farms or the farmers are the marginal or small farmer. Okay, so that is one of the things. Okay, so you have whatever the solution that we are talking, right? It should means it should be on the level that my these marginal or small farmers should able to do it. Okay, then only there will be some meaning on that. Okay, from Indian context I'm talking, right? And major crop point of view, you can see that in India, you'll find the rice, wheat, maize, okay, some coarse cereals, cotton, sugarcane, fruit, vegetables. Okay, so that's why you'll find in application point of view, majority of the works people are doing in the rice, wheat, okay, some in the cotton point of view. Okay, because that is our major productions in Indian point of view, right? Now, next is that the 60% of the cultivated area is a rainfed and the 40% is under irrigations. Okay, so that means you can understand the irrigation why it is a problems. Okay, because 40% of the our cultivation depends on this irrigation. So that may be the different kind of irrigations. Okay, so there what is the use of uh, the the smart technology. Okay, so from this you can visualize. Okay. So now, so this is our Indian scenario. Next, if you see that how this agriculture and revolution it happens, and actually this revolution happened along in the handholding of the industrial revolution also, right? So at the beginning, okay, very early days, right? Our agricultures totally people used to do develop their indigenous tool, and it is totally labor based, right? And me and also the you can say the manual or animal power, right? So and that is nothing but the we can consider agriculture 1.0, right? And then with the advancement of industry 1.0, okay, so these happened in between here in 18th century, right? Where you have the steam engine, water power, right? So those invention happened, right? So that also influenced your agriculture. Okay, so there it's the mechanization comes. Okay, your tractor, your fertilizer sprayer, the pesticide sprayer. So all those things is came, right? And that is actually the era that we used to call the green revolutions. Okay, and that under the that we can say it is agriculture 2.0, right? And after that when industrial 2.0, under that when the mass production electricity energy came into the pictures, right? So with the handling of that, we have the agriculture 3.0, right? So where you have the you can say the bit yield monitoring, okay, guidance systems, variable rate applications, right? So lots of other things came, okay, with this. right? So along with when now we are under industry 4.0, right, where we have to see what are the major technology is that under industry 4.0 we are talking the AI, IoT, big data, right? So on that visions again you have the agriculture 4.0, right? So we are actually under this currently with this agriculture 4.0, right? So where we are talking about more autonomous farming, trust the food supply, okay, ubiquitous agriculture sensing, right? So the moment you are telling every ubiquitous, moment you are telling the trust the right. So then from there itself we can understand that why it is the blending of AI and IoT is important, right? So I hope you can understand what is the motivation behind this bringing this IoT in the smart agricultures. Okay, now I'll just talk another important aspect. Okay, uh, if I now see these modern agricultures, okay, and the traditional agriculture, right? So what is the difference? You can see if I summarize the traditional agriculture, it is electrical, mechanical, and the modern tomorrow's means I am talking the industry under agriculture 4.0 point of view, right? It is mostly information driven, right? Next is traditionally is hardware oriented, but the agriculture 4.0 is a software oriented. And here it is manual and on-site control, and the agriculture 4.0 it is fully automatic and remote control. Okay. Traditionally, it is independent of the dumb machines. It is, and here it is network smart machines are there. Okay. And here you can have the predictability in the quality and quantity, right? So there is a lots of advantage that we are claiming, right? And what is the bottom line? That the science and technology, okay, so it allowed to produce more with less workers, right? So that is the overall point, right, under this agriculture 4.0, right? And what is another thing? So more choice in the food product than even um, throughout the years, right? So it is coming the throughout the year. Maybe you can cultivate a particular um, uh, the the crop, right? Which is earlier it is not possible, right? So that is a point. Okay, so there is a we can see there's a lots of success story people are talking, but is it really so, or is there success behind the success? Is there any other challenges, right? Yes, you see although we are telling that under modern agriculture, okay, we are doing so much automations, okay, the precisions we are doing, right? But still, you see, there is a these are the challenges are there. Okay, so we don't have any control and synchronization of the data, right? Because what suppose a farmers what is the fertilizer using, right? As a consumer, we don't have any information. We don't have any synchronization also. Okay, what one farmer is doing, what is the next farmer we doing? Maybe for the same crop, there is no synchronizations of the data, right? So that is first one. Next is the small farmers having the problem competing, right? So that already I mentioned. Okay, because they look for the which is much more profitable that things. Okay, how I can I don't bother about the quality and means maturity. I'm just bother about what is whether maximum benefit how I can get it, right? So that is another problem, right? Then coming to the malnutrition health problem due to inappropriate the food, okay, and many people complain about the taste of the fruit and the vegetables. Okay, so we are buying a good quality by looking, but when you're eating that time, we are finding that it is not the quality is not or taste is not good, right? So is there any quality and control thing is required? Okay, then the food safety, another problem, right? So there is a lots of problems are there, right? Even under the modern agricultures. Okay, so then that means what at the end we need is it is not should not be only smart agriculture. It should be sustainable and smart agricultures. Okay, so that is a point, right? So when you're talking about the sustainability point of view, okay, so there comes this the role of these AI and IoT. Okay. Now, what is the sustainable agricultures, right? So you're we are doing on top of the conventional agricultures. Okay, you're connecting different kind of sensors, right? Then smart technology like ICT, AIML. Okay, under smart technology, what are the different technology that we are talking? Like your the blockchains, your unmanned aerial vehicle, your robotics, nanotechnology, right? All those things when you're combining, right? And then at the end you are getting a sustainable and smart agriculture, right? So the with the vision that it will transform this manual labor and the low productive agriculture sectors into sustainable, intelligent, efficient, and more eco-friendly agriculture situations, right? So that is a overall our the goal, right? Now you can understand what will be the impact. Okay, so if we can do it, if we these again people are doing in a step by steps, but if we can do it holistically, so then you can see there is a lots of the benefit in all the aspect. Okay, because let me tell you one of the examples. Okay, because while working in one of our project, right, we used to go in the field visit in one of the village for the data collections and the testing of our devices. So in the interaction process, right, what you get to know, right, as I mentioned, the majority of the farmers are small or the marginal farmers, and they are more bothered about or interested that how I can get the maximum benefit uh, against what I have invested, right? And for example, if we take the paddy crop, right? Because then you'll find that they are more mainly they rely that what is the government MSP, okay, what is the total quantity that they bought, the government buy, okay, through the MSP. So their target is only to produce that. Okay, so now there is a challenge. Suppose a the government is buying, for example, is 10 10 quintals, okay, from a individual farmers. Okay, so now a farmer, if the land that they have, right, in a normal way, okay, in a controlled way, if we cultivate, he may not get the 10 quintal of the rice at the end of the day. Okay, so or the paddy, right? So he may get maybe say 8 quintal, right? But now what they are doing, they are they are looking for some means unethical way, okay, that I can say, that use the more fertilizers, okay, and so that they can get at least that the 10 quintals, okay, so that they can get the maximum benefit. So that is a way that people are doing, okay, means. So the point is that there is an uncontrolled use of these fertilizers, okay. So farmers is doing from their aspect, but at the end when you're talking about the holistic, the quality and controls, right, and even the farmers don't understand, if they over use the fertilizers with the time, the soil quality and everything will deteriorate. Okay, so it requires that much more, you can say, intelligent way or a smart way. Okay, so to address this. Okay, so this you can understand from this example, you can understand if you can really implement it. Okay, so there is a lots of impact, right? Now, when you're talking about the smart agricultures, okay, so then we are talking about the crop management, okay, then livestock monitorings, the remote sensing, smart irrigations, autonomous tractors, then also the agriculture supply chain or the marketing, right? So we are talking about whole things, right? So different groups, different people are working on the different the verticals. You can understand these are the individual verticals. Okay, so we'll also show the which are the verticals that we are working, a certain of the as an example of that, okay, of our work. So what is the benefit that we can get over this smart agricultures? Okay, so that already as I mentioned as an example that optimization of the fertilizer and the pesticide, okay, which is a big concern, okay, in today's time, okay, because in India context there is no standardizations, okay, on these agriculture sectors, right? So we need to have the proper standardization, and for that standardization and control, and for that we should have these IoT based solutions, right? Then real time data provisions we can get it, then greenhouse and the soil erosion reductions we can get it, then water conservations, okay, with a smart uses of the irrigations, right? then operational cost and the reductions, the crop production efficiency increases, right? So let me give you one of the example that water conservations. Okay, let's take the example of the irrigations, right? So you may ask, so already we are farmers are doing, right, the irrigations. What is a big deal on that, right? So as I mentioned, the 40% of our the cultivation depends on the irrigations. Okay, that may be my deep irrigation, that may be some kind of canal irrigations or underground water dependent, right? So now point is, okay, how the smart is currently what we're doing. So yes, currently it is yes, right? You can say yes, I'll have a some kind of soil moisture sensors, and if the moisture value reduces, there will be some pump. Okay, the pump will automatically on. Okay, it will irrigate. Okay, so and if the moisture the through after switching on the pump, right, if the soil moisture value attains a particular again the value, right, my pump will be off. Okay, so this is the one of the you can say the automatic IoT based solution is theirs, right? So now you can ask what is why required the AI here, right? Now try to understand. Okay, so these you are doing. Okay, these are automatic way that you are doing, right? And that your what is your sensing parameters? Your sensing parameters is only the what is the soil moisture value, right? Now we try to understand the situations. Suppose you through this mechanism you did your irrigations, okay, at the morning, maybe morning 8 o'clock, and then suddenly you found the morning 10 or 11 o'clock there is a rain happened. Okay, and if there is a rain happen, so what is the meaning? So suppose there is a good amount of the rain happen. Okay, so then so that water again may be locked, so you have to make some kind of draining things. This first thing. Second things, the earlier at 8 in the morning 8 o'clock, what is irrigation that you did, right? Now for that, what is the cost involvement, what is the water that you have used, right? So that is no meaning, right? So that's the coming, right? So along with this your field parameters, you take some other external parameters like your weather forecasting data and all those things, and then based on that you do your irrigations. Okay, so that means if you from your weather forecasting from this example you can understand, if we can now predict, yes, there is a chance, there is a probability that 10:30 there will be rain. Okay, so then if there is any that much emergency, so maybe I can do this is the optimized the irrigation that I can do. Okay, so this will be benefit from all both the aspect, like the farmers, the what is electricity that he has to bill, he has to pay for running that pump, right? That will also reduced. Then the my water wastage will also reduced, right? So that means you can understand what is the role of AI here. Okay, even in the my irrigation point of view, right? So this is the benefit that we can get it, okay, through the use of this IoT, right? So now we have seen the what is the traditional IoT architectures, right? So now if we bring that these IoT based or a smart agriculture architectures, okay, so then what you'll have here we again you can define as a 3 layers. Okay, so but now you see the layers we are defining with the defined new terminologies. Okay, so this first layer is agriculture device layer, that is as it is the your perception layers. You can understand in your agriculture field you have a defined entity, okay, your crop, your soil, your tractors, your cattle, right? Then your aerial vehicles, okay, unmanned aerial vehicles, right? All those things is there, right? And that your connectings, right? Through some kind of sensors. Then it is coming that your edge computing layers. Okay, so again, edge computing you can differentiate. Okay, why you are doing your computing is you are doing on the device itself or little bit on the gateway levels. Okay, so or little bit on the fog level, right? So in that way you can again you can define your edge computing layers, right? And then at the end you have a cloud computing layers. Okay, so that means you can understand or you can ask, okay, I am doing my analytics at my edge under the vision of IoT, then why again require the cloud? Okay, so the cloud actually there's a two objectives for the cloud, right? One is obviously your data analytics, and another important thing is your data archiving, right? You have to store your data, right? So this is one thing. Second things, in the edge, as I mentioned, there's a challenge is that the model reductions, okay, and the deploying at the end devices or edge devices is a challenge because you have a resource constant situations. Okay, so that means you can't do all the operations. Now, what kind of operations I should do? So that depends what is my most the delay sensitive operations, what is my most crucial operations, which I may not able to wait my cloud response. This is one aspect. Second aspect, as I am talking with the farmer point of view, right? So in the remote locations, I may not have the good communication with the connectivity. Okay, so but farmer want some immediate solution or immediate result of that. Okay, so that means I can't again make the everything is a cloud dependent. Okay, so I have to do some kind of edge dependent. Okay, through that I can solve it. But these other things which is maybe immediately you don't need, okay, in a long term, okay, maybe every 15 days or every 1 month you need, okay, so that I can do the cloud computings. Okay, so what is again the idea? Okay, whenever there will be networks will be available, the data will be synced with your cloud and the analysis will happen. So at the end of the crop season, right, you can understand what is happened holistically. Okay, so with that point of view, your cloud is also part of this. Okay, so again, you can understand in the connectivity point of view. Okay, you have, okay, I have subsequent slide. You can understand from there in much better way. Okay, so agriculture device layer point of view. Okay, so again, what kind of operations you are doing? Like if you are monitoring or taking data from your crop, right? So then it can be your underground sensors. Okay, um, like your soil moisture, soil pH, soil chemical composition, right? So different kind of sensors is here. Or you on the UAV based sensor that you are doing. Okay, so they are it is mainly we depending on the some kind of camera. Okay, so like your thermal camera means thermal image here. Through this you are getting some kind bringing some intuitions. Then RGB, okay, multi-spectral leader. Okay, so the again different kind of imaging mechanisms are there. Okay, and along with you are also taking the environmental parameter like air, humidity, the wind speed, solar, right? So these are the one category, right? Next, if you are working on the livestock, okay, livestock point of view, mainly we're talking about the wearable collar devices. Okay, so that we can use for the different applications. I'll also show you one of the application that we did. Okay. Next is your greenhouse. Okay, there we need the monitoring and the controlling of this light intensity, air humidity, temperature, perceptions, right? The soil moisture, soil pH. Okay, so under greenhouse again, you miss or similar kind of another technology that is also came the hydroponics. Okay, so they are also you require the room temperatures, humidity, water level. Okay, the pH, all those monitoring things, right? So that means you can understand based on your uh, the focus area again under the agriculture, right? The different kind of sensors or the sensing principles you have to look into, right? Then in edge computing point of view, what you have so again different hardware devices. Okay, Arduino, Raspberry Pi. Okay, so this is very popular, right? ESP32. Okay, Intel Edison, Beagle Born, right? So these are the again people have used for different applications. Okay, so many cases we are using this Raspberry Pi. Okay, in the IoT applications. Okay, so that's why Raspberry Pi is becoming much and more prominent under the IoT. Okay, but in traditional IoT, if you want to send only data, so there your Arduino or ESP is becoming more uh, dominated. Then in cloud computing, as I already mentioned, that you have a massive data, you have to save the data. Okay, because you try to understand if you are collecting data through your camera, right? So that means your image data, which is very difficult to process at my edge. Okay, so that means maybe you will require to send to your the cloud, right? Suppose you're collecting data through RGB image. Okay, means RGB camera. Okay, so that means you have a 3-band. So your image complexity is, you can understand, little bit less. Okay, but if you are using multispectral image or hyperspectral image camera, right? So that means there you will not have only 3-band. You will may have a 7-band. You have maybe 10 bands. Okay, so that means what is the image that you have captured, right? The image dimension you can understand totally change. Okay, so in RGB point of view, you may have a means matrix dimension. Okay, 3 channel means I can say that you have a 3 column value, right? But the moment you have a suppose 10 band under the multispectral image, okay, so then your whole dimension change from 3 to 10, right? So that means your the computation complexity increases. Okay, means data complexity increases. Okay, so that means you may not able to do the your multispectral image analysis at your edge. Okay, so that means for that you have to use your the cloud layers. Okay, you have to depends on your cloud layers. That is our idea, right? Now network point of view, yes, the short range networks. Connectivity point of view, you have a Zigbee, Wi-Fi. Okay, so again, see these connectivity layers and layer 1, layer 2, what is the main difference? You can understand. The layer 1 is actually the um, the unlicensed versions, right? Or ad hoc networks that we are talking, right? And whatever is the connectivity under layer 2 or connectivity type 2, right? Which is mainly the your licensed version, okay? Like your mobile um, the 3G, 4G, or 5G technologies that you are using, right? So that is your license version. Okay. Now, in agriculture point of view, see this long range communication is becoming more popular because in agriculture field it is wider, right? Now, so you may not get your that all the field coverage using the short range like your Wi-Fi or Bluetooth communication, right? So there is becoming more popular about this LoRa. Okay, so LoRa, Sigfox, these are the unlicensed one. Okay, and along with this, the new another communication technology is came with the NB-IoT. Okay, which is nothing but the narrowband IoT. Okay, so this is a combination, little bit. It comes under the vision of this uh, the 5G. Okay, so NB-IoT. So what is that NB-IoT? So uh, you may know, right, in any communication systems, okay, means you have a 3G, 4G, or 5G, right? So if you see, right, you have a spectrum, right? So now, in the spectrum itself, you'll understand there will be some guard band will be there. Okay, so I'm just I'm making an analogy. Like if you have a road, right? So if you have a 2-lane road, right? So what you'll have, suppose means you see that in between the 2 lane, right, you will have some kind of the guard path, right? Which maybe people are using means in normal roadside we have seen, right? They are putting maybe their means light post, or they are maybe using putting some kind of trees. Okay, so that they are using, but they are not using that is a normal the traveling purpose, right? So that we can consider that is some kind of guard band is yes, okay, which is separating the two side of the roads, right? The same way, in a spectrum also, they will also have some kind of guard band. Okay, so now what is this NB-IoT is doing? So that guard band is not used for the normal communication purpose. Okay, so now under this IoT, because see IoT suppose temperature sensor. Okay, so it is sensing the data, right? So that data bandwidth requirement is very small, right? So that the data which is having the very low bandwidth requirement, right? So that you can send through that guard band, right? So that means you are maximizing the utilization of your spectrum. That is overall idea, right? So under that your NB-IoT concept is came, right? And that you can use for again for the long range communications. Okay, so that is a benefit of this NB-IoT. Okay, people are using. Okay, but overall in agriculture side, okay, if you see in today's time is the real field deployment point of view, LoRa is becoming the most dominating one. right? So in IoT based smart agriculture cycle, okay, if you look into, okay, what you'll have, you'll have data collections, okay, so then data processings, right? Then your prognostics, okay, then you have your solutions, and at the end you will have your actions, okay, or what measures you have taken out of that, right? So this is your whole cycle, you can understand, right? So now when you're talking about the AIoT, okay, so there another terminology, maybe some of you heard about, okay, those who working on the ML. So that is called the tiny ML, okay, because the ML model you are making in a smaller version. So that is the name, it is a tiny, and that you are bringing on and at your edge level. Okay, so that means from here you can understand your data collection is yes. Now your data processing prognostic solution that you're doing at the edge level itself under using this tiny ML concept. Okay, so that means these entire things, okay, these data processing, prognostic, the solution, entire these three things now we are bringing under your edge level. Okay, so that is the difference, okay, between the traditional IoT based process or the cycle and the IoT or the tiny ML based process, right? Now just another point that in agriculture point of view again, as we are applying the IoT, means we are collecting huge number of data, right? So actually we are generating the big data. Okay, so as you have a, if you think from the big data point of view, yes, then we have to look into the cloud computing. Okay, the edge computing and IoT will not be feasible on that context, right? So so now I hope you got the again the basic idea about this agriculture and smart agriculture. What is a smart agriculture, right? So now I'll discuss how we can build up an IoT based solutions. Okay, means bringing the model at the edge, right? What are the devices, what are the again the challenges or things that I have to look into. Okay, let's see it. Okay, so this is again a generalized architecture that I have shown. Okay, so IoT context, you will have different layers, right? So now it will start, everything start from your physical layers. Okay, so in physical layers, what you have your sensor node, right? So sensor node, what is the means architecture of your sensor node? Okay, you have a different kind of sensors that are connected in the different objects, right? So and then you have some kind of computer, okay, or computing devices or some kind of microcontroller, you can understand, right? Now based on your data type, right? So if it is analog sensor, right, so that means you can the sensor directly can connect to your microcontrollers. If it is not analog, if it is sensor is generating the sorry, if it is a digital, so directly you can connect to the your computers. Even if it is analog, so then in between you have to connect some kind of ADC. Okay, so it comes that um, you can take the some microcontroller which is having some inbuilt ADC like your Arduino. You'll find there is a certain analog input is there. So that means there is ADC pins. ADC's functionality is inbuilt on those pins. Okay, but whereas if you take the Raspberry Pi, okay, it does not have any kind of analog pins. Okay, that means if you are connecting any kind of sensors which is generating the analog signals, you have to at first add a ADC module, then you can use the your Raspberry Pi, right? So this is about your computing devices. Next, what you have, you need the radio module. Okay, means that radio module, it depends which communication techniques you are using. If it is a LoRa, so you have to use a LoRa module, right? Then what you have, another important component, your power, right? Because in agriculture point of view, if you look into my sensor data, sensor is connect or sensor node is placed in a agriculture field, right? So there I can't power with my traditional power supply. Okay, so I have to depend with some kind of battery, right? So now the battery, again there is a challenge. um, the battery the will drain. Okay, if you are using normal battery. Okay, so there is coming now. I have to make some kind of rechargeable battery. Okay, to make it more sustainable. And so that means rechargeable battery if I'm connecting, so that means I should put some kind of energy harvesting system also. Okay, so in agriculture point of view, you'll see that solar is the major component, okay, and under this the energy harvesting. Okay, so then the moment I'm putting my solar, my the rechargeable battery, right? So there again, it's coming that your power management unit again should taken it properly, right? Now let's see. We'll discuss one by one component or major component from sustainability point of view. What we required, right? So first is the your sensor. Okay, your sensor node. The first and foremost things we can understand the sensors. Okay, so how will identify, how will select your sensors. Okay, so while selection, there is certain selection guidelines that we have to follow. Okay, so which is nothing but your sensor characteristics that we have to consult, and our requirement and the sensor characteristics should match. Okay, so then only you can get it. Okay, so sensor characteristic point of view, it should be I have to look into my range, right? Your accuracy, um, precisions, resolution, repeatability, because that I have to see, right? What is my resolutions? Okay. Now, you can understand with a very simple example. Okay, what is a accuracy and resolutions? If I take my temperature measurement on of the case, right? Suppose you are measuring the temperature of that field temperatures. Okay, so can you use the temperature sensor that are using for human body measurement? It will not, because human body, you see the temperature range and resolutions um, is something different than the field temperatures. Okay, because human body temperature, I can consider the range may be 35 to 43. Okay, but what is environmental temperature range may be the 5 degree to 50 degree centigrade, right? And so I need different sensor for that. Okay, next is that your repeatability, reproducibility. Okay, so whatever the sensor node that you're making, it should be repeatable and reproducible. Okay, repeatability means you can understand. Suppose you are performing the experiment today. Okay, means if you continue next 30 day, if you're measuring the same means quantity, it should give the same value. That is the meaning of the repeatability. Okay, reproducibility means suppose you are measuring the soil moisture value in one field. Okay, and using the same sensors you are measuring in another field. Okay, for the same soil moisture content, your sensor should give the same value. So that is meaning the reproducibility, means you're changing your environment or changing your field. Okay, sensitivity, yes, these also you have to select properly. Selectivity is another things, and linearity is also important. Okay, so we have to majorly see. Okay, so what is my requirement? Okay, and what the, because as I mentioned that I may have the different kind of temperature sensor, but which temperature sensor I should go for? Okay, so that selection I have to do. Okay, uh, based on these justifying these characteristics. Okay, next I have to look into certain other situation or other characteristic of the features of my IoT sensor node. Okay, the first is I can consider my physical constant. Okay, the size. Okay, because I can't make too much bulky, right? So it should be very compact in size. Next is that your battery power and energy harvester means again overall I am taking the size. Okay, because you can't put a very large solar cell also. Okay, because you may think okay it will generate more energy, so I'll connect a huge solar cell. So that might not be possible in all the cases, right? Next, the what is a lifetime? Because the lifetime of your sensor node is important, right? Because a lifetime defines what is your the battery lifetimes, right? Then interaction means when you're doing interaction, so it comes whether it is always connected or you're doing a schedule based connections, okay, or duty cycle based of connect the interactions, okay, because you know from the energy point of view in sensor node what is a major the energy consuming device is your communication or radio module, right? So if you turn your radio module throughout the time, you'll find your battery will drain out within a very short time. Okay, so you have to make that duty cycle mode. Okay, and accordingly you have to program your sensor node. That is my point, right? Next is trade between computation and communication. So that already we had discussed. Okay, so means with the edge computing, which is the immediate requirement that you do computation at your there, but which is not immediately required, that you send to your cloud. Okay, and let it be theirs, because if you are totally doing at your sensor node itself all the computations, so again that is coming that it will take the huge energy. Okay, so energy is limited. That is another point. And user interaction point of view, so as I mentioned, we are developing this for the farmers. Okay, so it should be very cost effective. Okay, you can't come with a very costly things, right? So then it will not be a sustainable solutions, right? And also the security, right? So as I mentioned that you made doing your computations there. Okay, so you're taking some important decisions, right? So your device and should be secure. So device security is coming, means hardware security. And along with maybe you're also sending some the at the end the what is the decision is taken or the data for your data archiving purpose in the cloud, right? So the data security is also there. Okay, so again the sensor node point of view, I can't talk about the heavyweight sense security protocol. So I have to look into some lightweight security protocols, right? So and with this vision, actually, these blockchains means the lightweight blockchains, or you can say the tiny blockchain is also coming to the pictures, right? The which you can deploy at your edge devices. Okay, so this is one of the example that in our group we have proposed for the sustainable sensor node for agriculture IoT. So these you can understand that this we connected with a solar panel and a rechargeable battery. Okay, uh, so now again, what are the challenges associated? Okay, so the moment you are connecting your rechargeable battery and the solar cell. Okay, so uh, um, the- because we are talking about the sustainability. Okay, so it is coming that the battery that you have connected, right? So it will also the battery performance or the battery life will degrade. Okay, so because you can understand, if my battery or energy is not there, right? So my sensor node is off, right? So then everything is gone, right, in under the IoT. Because if battery is not there, sensor node is not able to send any data, means there is no meaning, right, on that, right? So I have to take care of that, right? So with this aspect, you can see the what are the challenges associated with the rechargeable batteries, right? So the mainly rechargeable battery point of view nowadays, lithium-ion batteries is becoming more popular even in IoT node, right? Fabrications, like it has a because of the it has a lower self discharge and prolonged battery life. Okay, but there is a two important factors that we have to see, because this lithium ion battery also it degrade with time and also with the load that you are connecting. Okay, so this life or the means of your battery that you can define with these two terminology. One is we call the state of health, right? So which is nothing but the short term battery health indicators. Another is your remaining useful life, or RUL. Okay, so that is your long term battery health prediction. Okay, so what is sustainable IoT point of view? What is required that the whatever the rechargeable battery that you are using to power your sensor node, right? Um, and as I mentioned, the sensor node life depends on the your battery. Okay, so I have to also have some kind of mechanism to predict the battery health on my device itself, means on my sensor node itself. Okay, so that is our idea. Okay, so with this visions, we have developed or we have proposed a intelligent thing, and that we name as I think. Okay, so for the sustainable IoT applications. Okay, so what is a new addition is here. So already I've shown that what is our sensor node architectures, where you have the controllers and the battery. This part is theirs, right? And yes, we are doing the energy harvester, so rectifiers, converter part will also come, and allowing the battery management part, that will be theirs, right? So, and external sensors, so that is already it is theirs. Okay, now what is a new thing that you have added is we connected and current sensors, right? And we have introduced another module that is called the your SOS or prediction module and RUL prediction module. Okay, means inside this sensor node, right? And that actually that module is implemented under these controllers. Okay, so from this what we can get it. Okay, means on side there is external sensor data that will communicate as it is going on, and along with the internal health data of your sensor node or your battery, that will also be transmitted. Okay, so this is for the internal quality, right? Means for sustainability of your sensor node, it is important, right? So that's the thing that we have proposed under this, I think, right? But again, the challenges is that as I mentioned, the this RUL and means the SOAs that prediction, right? Means prediction. The moment I'm telling, it should be some kind of AI model, right? So that should be again deployable in my microcontrollers. Okay, inside the microcontrollers. Okay, so then only I can or this is our vision that we can get it, right? Now for that we this is our the proposed prediction step that we have it. Okay, and so this is one of the work that is recently it is published in IEEE instrumentation measurement, right? So here we have taken the battery data, right? And from this we are actually calculating the one of the health indicators that we name is a TIECVD. What is that? So it is nothing but the time interval equal charging voltage difference. Okay, because you see, as a battery degrades, so this uh, the time to the interval to achieve the same voltage difference, okay, is actually it decreases. Okay, so that we have taken one of the health indicators. Okay, and that we send to an ELM networks. Okay, and from this we calculated our SOH, and these SOH and along with this earlier that health indicators we send to another neural networks, RBFL networks, which extract the your RUL, means which is nothing but the remaining useful life, right? So so this is the basic concept of this TICVD. Okay, so now the ELM, why we have selected? Okay, because it is a less computational burden. That is the first point, because I want to do on my sensor node. That is first thing. Same thing is that it has a the fast learning speed, right? And also it is a good generalization capability. Okay, what do you mean the generalizations? Because you may sensor node point of view, you may connect the battery manufactured from the different vendors. Okay, so that means my model should able to handle all the varieties of my the battery, right? So that is a point, right? This is one thing, and also and to mimic that, what we have tested different battery which is having the different charging policy and also the lifetimes. Okay, and then from there, so this is the result of our SOS predictions using this ELM model, right? So this you can understand the accuracy is quite good, right? And also you can understand the what is a runtime. Okay, is a in a very short in a very few millisecond we can get what is the means SOS or state of health of the battery. Okay, in the by sitting at my sensor node itself. Right? And to further validate, we varied the different um, means testing starting point, because I may have my battery in the different situations. Okay, different situation means in different health conditions. So to validate that, okay, so we have done it. Okay, so from there you can understand the effective this SOS prediction during entire lifetimes. We got in with a very good accuracy, means with a very good means RMSE value point of view, you can understand. Okay, and also we can understand the bit, even we can predict if the prediction is started at the later point. Okay, means at the later stage also we can do it. Okay, initial stage is easier to do, but later stage when you have a exponential decaying, then also we are able to do it. That is the our one of the claim. So after getting the SOH, our objective is to find the what is the remaining useful life. Means after which day or which time I should change my whole battery. I should throw it. Okay, so that user can do it. Because you can understand one point, when you're deploying the IoT solution for agriculture applications or on field, right? So I'm not deploying for with a means with the vision that my sensor node will run only for few months. Okay, I'm looking for it should run few years, right? So then only there is a meaning that what is the investment installation or the infrastructure development investment monetary point of view that I'm using, right? It should be justified, right? This one thing. Second things, I have a in means hundreds of sensor node on my field, right? So it is not possible for a farmer or for any users that go and check, right, what is the health or what is the condition of the sensor node, whether they are working, functioning properly or not. Okay, so that should be some intelligent way. It should also address. Okay, so that is our overall idea. Right, so so with this RUL also we have achieved the low error values irrespective of charging policy. Okay, and also RBFL why you have selected because of this less computational time. Okay, so that is a point that I mentioned, that always you have to look into that which is having the less computation, less complex. Okay, that model. Okay, and this finally we have also validated with one of the pump, one of the agriculture motor in the pump which is used. Okay, and so this is the point, and also we can see that what is the power consumptions. Okay, while the execution times, the model execution times also the it is taking very less power consumptions. Okay, so effectively what we can understand, what we try to establish that yes, to make my practical sensor node sustainable, right, I should also look into my health of my sensor node is one of the important parameters or in important component is my battery. So battery health also I have to monitor, and it should predict and it should alert the users when it is going beyond a threshold value, right, to change it. So with this, we have further extended this work to render the sustainable sensor node. Okay, falter, and that we name it the sustainable point of view in the sense. Um, so we you can understand that as I mentioned that your sensor node is sending the data, right? So but your in between my data may be corrupted, right? So what will be the integrity of the data? Okay, whether data is tampered or not. Okay, with this, what we did, we have introduced the concept of these blockchains. Okay, so which actually takes care about this data integrity, and along with that your RUL and SOS predictions. Okay, as it is doing, right? So so this blockchain is used for the data integrity. Okay, means to avoid the data sampling. Okay, and actually this it means because after sensor node you have a gateway, right? So the checking is happened between the gateway and the sensor node. Okay, and if there is any mismatch in the this hash value, because blockchain point of view, you may know there is some hash value that we send, right? And if there is any mismatch, so then we it gives an alert alarm that there is some data tamper happened. Okay, so please take care. Okay, so that is a way that we have further extended by connecting with a different sensor node, connecting with a different kind of sensor. Okay, so because you can see in sensor node 1 we have used the camera module, and sensor node we use some temperature and humidity. Okay, which is measuring the field temperatures. Okay, and in all the cases again the what is my the RMSE value, that also you can understand. Okay, so this is the sensor node point of view. Okay, so that's the things that we are working, right? Now let's see some few of our specific example on the smart agriculture. Okay, so what we are working, right? So this is as for your reference. This I have categorized that the IoT application is smart agriculture. What you can do, smart monitoring application. So that may be a crop monitoring, livestock, environmental, field monitoring, the remote sensing, motion detection. So many things you can do. Then smart water management, then agrochemical applications like your fertilizer, pest control, herbicide, the solar pest, UV-based agrochemicals, spraying, weed detection. So right, all those things coming under agrochemical. Then it's coming disease management, then smart harvest, then supply chain management and agriculture practice. Okay, so broadly you can define or you can see the applications of IoT in smart agriculture in this field. Okay, so based on your interest or what you feel that this is the real requirement in Indian context, okay, you take it and you'll find there is a respective the research challenge, research problems, okay, and you can solve it, right? Now let's come what we are working. Okay, so first example. So we defined an AIoT based framework for enabling digital agricultures, and that we name that technology as a farm edge. Okay, because we are doing all the decision at the edge. Right. Now if you see in general what is the challenges or the research gap, okay, so you'll find the crop monitoring point of view, if you say, because these I'm talking under this smart monitoring, okay, crop monitoring point of view. So majority of the solution that already what is there, right? So that is cloud dependent. Okay, but the point that I mentioned for Indian context, right? So the where my field is here, right? You will not have the good connectivity. Okay, means it will be more severe case if you are going some kind of tribal locations, because that will be more either the forestry area or a hilly area. Okay, so there the connectivity is very difficult. Okay, so you can't depend a solution the cloud dependent. Okay, so it requires that it should be on the edge dependent. That is the first thing. Second thing is, the moment you are talking the edge dependent, right? So then it's coming the accommodating the low space handle device, whether you can do or not. Okay, so that you can do your the cost optimizations, right? Second things that what are the different hill that we can do it. Okay, so there it's coming the stress on the crop, so that maybe stress can be a biotic stress and diabetic stress. Okay, so that detection is important, right? So now in this context, let me give you the example that what we have done it, right? So we have named this is a Farmage, is a Farmage frameworks, and it has a two version, okay, on hardware device and also the smartphone versions. Okay, so what you can do your live farm data. Okay, what is your the environmental soil parameter, that everything you can get it. Then you can also have the crop growth. Okay, what rate the crop is growing, right? Then the irrigation part. Okay, and then the what are the disease, right? So that everything's we brought into the one platform. Okay, so one by one we'll see. Okay, as a case study what you have done it, right? Now, yes, um, so with this, we have developed a IoT Kishi node. Okay, we name it as IoT Kishi node, and then it is IoT networks. So, and that we name as IoT Kishi networks. Okay, so which majorly it's do the field monitorings. Okay, like live data of the soil moisture, NPK sensor data. Okay, then your environmental temperature data, and then crop field tracking, right? And the water monitoring means irrigation point of view. Okay, so these respective the IoT sensor node is take cares that. Okay, and then at the end it is collected. Okay, So this is the snapshot of our first prototype level, right? And the performance also you can see. Okay, and this everything is including our sensor, soil moisture sensor, NPK sensor that we have developed indigenously in our lab, right? Next is the crop health monitoring. So now in crop health monitoring, so it is mainly the image based. Okay, now let me tell you that as I earlier also mentioned, in today's time, this smartphone you can use as a one of the IoT or sensor node, right? Because if we recall the sensor node architectures, what you have a some kind of controllers, you have a sensors, you have some battery or power management unit, and some radio unit, right? And along with a certain memory, right? So this is your sensor node architectures. Now, if you look at your smartphone, you'll find all the thing is present at your smartphone. Okay, so with these visions, right now, people using smartphone as a IoT sensor node, right? Because you have your sensors, maybe your camera, right? You have your processors, you have your communication modules, right? So then you can use your respective smartphone is one of the individual sensor node, right? And that also we have identified a right choice because the farmers nowadays we can understand each and every family at least having a mid-range or the low configured smartphone. Okay, so that is our target. Will not go whatever the AI model that we are talking. So it should be deployable in this mid-range or the low cost smartphone so that the farmer can use it. So that is our overall idea, right? So again, with this, we have developed this the mobile applications. Okay, so means where the our entire deep learning model is deployed in the mobile architectures. Okay, so now while this deploying the model, right? See, developing a model is in today's time is not a very big deal. Okay, because there is a lots of what people have done, it lots of resources here. Okay, but main challenge is to bring that model to some resource constrained devices or edge devices or even in my smartphone. There is a huge challenge. Okay, and that is a part now people are more working both in academics and industry. Okay, because when you first we develop, so our that model is size is 680 MB. Okay, so the 680 MB that it is a very big model. Okay, so that you can't deploy in that low configured smartphone. Okay, so that you need to be make it shrink. Okay, so for that to use this concept of this tensor flow light. Okay, the API using that we did that conversion and we deployed finally successfully deployed in the edge model with a we are although there is some compromise in the accuracy but with a good optimized accuracy we are able to do that. Okay, so that is a point. Okay, so now how we can deploy this model. Okay, so this is one of the example. Okay, so it may help you. So you see, so it will have the two part. One is that your deep learning model development, and it is your Android app development. Because at the end, in mobile phone I'm deploying is I need some kind of app, right? So Android app and the that your deep learning model. Okay, so that will start. Okay, means two parallelly, right? So then you do your image processing, ROI extraction, data split, training, testing model, right? I'm not going to that part, okay, but these entire things you do it, right? Then mainly we use a Python ID for this, okay, and you train your networks, right? And then this, as I mentioned, using this TensorFlow Lite, okay, you bring shrink that model, okay, and bring that dual model, which is deployable and your or integratable to your mobile app. Okay, what you have developed using some Android platform. Okay, and then we can do it. Okay, so this is the overall flow. Okay, so one side you have to start developing your model, right? So that maybe your deep learning or machine learning model, and the side your mobile app, and then finally both the things you have to combine. That is idea. Okay, and then our solution, this we have compared with many of the already and the commercial one. Okay, and then our major claim is that the ours is edge. Okay, we can do the these computations. Okay, this detection, the crop monitoring, so crop disease detection at the edge. So that is our claim. Next, as I mentioned, we further extended that it is not only disease, the farmers are more interested to know, or technically it is much more suitable that what is the stress. Okay, now stress can be two types, can be biotic stress and abiotic stress. Okay, biotic stress caused by the certain fungal or the bacterial diseases. Okay, so what kind of diseases it happen? Is it bacterial or fungal? Because based on that, the pesticide will decide it. Okay, so you need to have that information. But again, the idea is that it should be the smartphone based solutions. Okay, so the what is the model that you're developing, it should be deployed on your smartphone. So that is idea, right? So again, in this case, it start with the image pre-processing, then train model, then classifications, then biotic stress prediction, and finally the deployment of that model. Right? So this is the overall flow. Okay, so these works actually published in IEEE sensor journals. Okay, so this is we for this we have built our own custom model. Okay, so and that also we have compared with all the other lightweight model that I mentioned, the mobile net, inception net, right? And you can see the accuracy of that our model, okay, over the others. Okay, and these works we did on the rice crop. Okay, so now we have collected the rice. This biotic stress data in collaboration with one of the agriculture university, right? And then on top of that, we have applied this, we developed these solutions. Okay, and then our overall test accuracy is 93.25%. Okay, now we have deployed this model, and we also did the field testing and the other illumination testing, because as you are dealing with the image, right, and also it should be done on the field, right? So you have to do the your accuracy testing on this the illumination and the background noise point of view, right? So this is also we can see that the how our model is robust in all the situations, right? And then we deploy that model in the these three different version of the phone, right? And we can see that the turnaround time. Okay, so it is within 15, within average. You can see the maximum in Redmi 9 Prime, right, which is 21, and OnePlus Nord, right, which is 10, because it is little bit higher configured system, the OnePlus, right? So even in the Redmi 9, right, which is a mid-configured smartphone, okay, that we are getting within 21 seconds, we can get that our result. Okay, so after this, as I mentioned, another part of this, the monitoring the growth, okay, of the crop, right? And for that, although there is a traditional technique is that the experienced farmer can easily do it. Otherwise, the leaf dimension index-based techniques is theirs. Okay, but those are the manual techniques. Okay, so the motivation is that the if we can accurately measure the growth of the plant, okay, so then you can optimize the what is the fertilizer level it is required. Okay, and the time to use the fertilizers, so you can do much more precise uses of the fertilizers. Okay, so that is our idea. Okay, so now with these motivations, we proposed or we developed a solution so that we name as the Internet of Leaf thing. So what we did here, we are monitoring the leaf. Okay, because the leaf dimension basis we are trying to do it. Okay, so we connected a Raspberry Pi and a Raspberry Pi camera, and along with the ultrasonic sensors, because as the dimension we are looking for, right? So it should also have some reference distance. Okay, because image point of view, if it is very near, so then your dimension will be bigger. If it is far away, dimension will be low. So that's the what is the separation between the or distance between your camera and the target, that should be fixed. And for that we have connected ultrasonic sensors, Okay, and then we captured the image of my leaf, and then we do the image processing techniques, and finally we developed again a age prediction model, right? And which can predict the age of the leaf or the plant, right? And here it is showing the different index. The different index is the different leaf at different stage. Stage means at different the height. Okay, because this you can, so this may be index 1, this may be index 2, this may be index 3, this may be index no, 5. Okay, like this. Okay, so we collected, and then from this we also predicted what is the age of the plant. Okay. Next, this is another example of that IoT-based solution for the cattle. Okay, so here our aim is to see what is the cattle activities and also the health of that cattle, right? So for that we have devised a smart collars. Okay, so which is having the important vital measuring sensors, and along with the means activity measuring sensor like accelerometers. Okay, and it can measure the temperature, the pulse. Okay, certain other parameters also we have, but maybe I didn't put it here. Okay, and along with also it required to see that what is its activity. The activity classification is also important, because the farmer point of view is required that enter the day what is my cattle activities. Okay, so the like eating, stationary, walking, right? And because from the activity again it can identify, now we can predict if there is any certain disease or the health issues involved or not, right? So this is another solution that we have developed, right? And then in continuation the earlier one, right? So this is another example that the low cost chlorophyll content quantifications. Okay, so because in traditional techniques that we have found, people use speedometers, and it is costly, right? So in Indian context, can you how we can do it? Okay, so for that again we developed a IoT based low cost chlorophyll the content um, uh, quantification systems, which we can measure it and send to the cloud, and actually we are merging these and this growth. Okay, so that we are bringing together, that work is going on. Okay, now, so this is related to the crop monitoring point of view, crop and the cattle monitoring point of view. Okay, and then parallelly, that another side that we are working, that is the irrigation, smart irrigation point of view. Okay, so in smart irrigations, we have identified, yes, whenever people are doing the irrigation from the either underground or the canal or the river, right? So the what is the quality of that irrigated water, that is also important, because if the quality, if the irrigated water having lots of heavy metals, or the quality is very bad, right? So that will also actually affect the first of all the plant growth, or second is when we consume that particular crop or the vegetable, right? So that also causes lots of the health issue on human body. Okay, or maybe that many times people are talking the that is one of the reason for the many of the cancers, right? So also need to have the quality monitoring system, okay, when we are doing these irrigations. Okay, so with this we have developed these solutions, and that we name is at um, the the groundwater quality system. So this is the architecture. So when you have the irrigation system, that itself we are putting our sensor node, okay, which will measure the quality of my sensors, okay, with respect to temperature, pH, turbidity, and then that we are sending, okay, through the cloud interface, okay, and so this is one of our deployed or the testing setup, right? And it has two versions. One is your smartphone, the app, right? And another is your the web versions. Okay, so farmers, based on the farmers, it means mobile functionalities, he can get the access of both, right? So again, the collected data, it is not only threshold based decision, it is again the learning based decisions. Okay, so based on that collected data, we have defined our own water quality index. Okay, and that from this graph we can understand the original and the ML model, how they are able to predict it. Right. Next, as I mentioned, that along with your smart sensing and intelligent decision taking, it is also parallelly important that the security and the traceability of this data. Okay. Now come to the agriculture point of view. Okay, agriculture, smart agriculture point of view. When the people are using nowadays blockchains. Okay, in what sense? So there it is coming mainly the agri-food supply chain point of view. The blockchain is becoming more and more useful to make it transparent on the transactions, and also the tracing the items in the whole blockchain networks, right? So with this concept, what we did, we whatever the our IoT Kishi node networks or the soil our parameter measuring devices that we have, right? So there we introduce these blockchain techniques with the vision of what? Because now it is required that what is the fertilizers, as I mentioned, the soil fertilizers that farmers is using, that should know about the uh, about that usage of the fertilizer. The user, the customer should know. The government also should know. Government, why? Because every farmers get a subsidized fertilizers rate from the government. Okay, but whether but this fertilizer, subsidized fertilizer, is come through some, again, some medium. Okay, so she required that what is the total the fertilizer supply chains, and also the fertilizer that farmer they're using, right? So whether there is a proper synchronization and the trust things is required. Okay, so with these visions we have used these blockchains, and our innovation here is that we introduce these blockchains on our sensor node itself, means on our microcontroller itself. So that's why we name is a soil chain. Okay, these things. Okay, so then what will predict at the end, what will give that if the it crosses the safe level of the chemical fertilizers, sorry, within the safe level, it will show yes, your product, what you are cultivated, it is safe. If it is beyond that, so it will show it is a dangerous, okay, dangerous to consume. So with this way that we are working on this fertilizers point of view, it's a blockchain concept. Okay, so this work is undergoing. Okay, so just to show our idea, so I'm just mentioning here, right? Next, let's try to see what are we have seen so many applications and uses of this IoT and AIoT in smart agricultures. Okay, let's see what are some challenges in smart agricultures. Okay, so if you see the challenges point of view, yes, you required good networks and connectivities. Okay, as I mentioned. Okay, so you have to deploy, maybe you have to look for your deploying node or own ad hoc networks. Okay, so how will do that is again a challenge. Okay, from Indian farmer point of view. Next, the power consumptions. Okay, as you're deploying it on the field, right? So battery driven. So and you may require some computation there itself. Okay, so it required the power consumption is one of the challenges. Okay, next. Reliability, as it is deployed on the field and the harsh environment, it should able to handle it. Okay, so the reliability of the whole system, okay, is important, right? Then your hardware availability and security, that is another point. Third is a data security and privacy. Okay, and overall that we are getting the big data, right? It is generating, right, handling of the big data and the selection of the right artificial intelligence and another important things, right? Because the data and the model point of view, if you see, right, data quality, your model accuracy, everything is depends on the data quality. Okay, and the reliability, validity, objectivity, and completeness of your data. Based on that, your model accuracy will be defined. Then the you may have certain other machine learning issues that I already have mentioned. Okay, like the high computation resource requirement, less class imbalance issue, okay, class imbalance issue, large amount of the data requirements, right? So all those things, again, it is important, right? Then you're integrating the model to the edge devices. Again, I'm emphasizing is a challenge because of the limited resource and energy, right? So that is the major challenge, right? Now, what are the research problem or open research questions in this way? Okay, so these you can understand. So technology perspectives. So you may require more extreme temperature operable sensor, real-time data analysis decisions, thermal or infrared image data set from the crop field. Okay, these people are working, but data set availability is limited. Okay, then tiny ML devices, low computation decision model, data compression methods. Okay, and at the end, for research point of view, require the public data creation, means integration in one. Okay, in blockchain point of view, as it is just introduced. Okay, the immutable data storage mechanism, optimization of the computation resources, optimizing the design time, right? And hardware security point of view, it's come the your path is becoming more useful. Okay, now we have to see from the agriculture sensor node point of view the usage of this path. Okay, and the network perspectives. Okay, so again, you have to make a networks which will also work in a natural disaster time also. A network should not have too much delay, and overall the data integrity should have maintain. You should able to cover more area, means, and your network should equipped with the wire and tear. Okay, it should able to handle that. Okay, and also the vandalism, that is another problem. Okay, um, for real deployment point of view, right? And along with the other cyber and the social financial point is yours. Okay, so these are the defined the open research problems that is there or people are working towards this, right? So at the end, I can conclude with these key perspectives that at the end, what we are going to achieve if we can implement this IoT for agriculture, okay, and even with the Indian context, because I started with that. Okay, so Indian agriculture GDP or average per acre for farm production will change substantially. Okay, then IoT, the coverage of technology will offer immediate productivity enhancement, right? Farmers will always be connected with the farm activity, right? That is very, very important. Then predictive tool and models shall lead to better control and security of the crop, equipment, livestock, okay? Then minimum control price regime may be eventually ended, right? Because when you have the proper control of the food supply chain, right? Then zero chemical input for the food production will become a reality, and protection of the biodiversity and the environment and deployment of technology will help addressing the and other subsequent other challenges in the agriculture sectors. Okay, so with this, I'll just end my talk. Okay, and we can discuss if there is any queries from audience point of view. Thank you.
Okay, thank you, sir. I request or I advise all audience or participant, your mic I have just allowed it, so you can unmute and ask few questions to sir. So it will be a bit interactive, so it is good. Sir has given a lot many research direction also. So 1, 2 at least. Okay. Yes,
Hello.
sir.
Yes.
Good morning, sir. Sir,
Yes. Good morning.
for providing so many different research area ideas. Sir, you saw a motor with some sensors, Sir, is it operating? Means the farmer is operating far away from.
No, that we have tested in the laboratory conditions. We didn't bring on the field. We have taken a motor, okay, and on that we have tested it. But it is in campus environment, okay, not in the real agriculture field environment.
Sir, is it like means the objective is the farmer will trigger the motor from his home? That is the objective.
No. See, the already the motor or pumps is there in agriculture field, right? So there you're putting your sensor node, isn't it? Okay, so objective is that so that your sensor node that you are connecting with the battery, right? Right. So what is the quality of the or the state of health of your battery? That also you need to monitor it, right now. Okay, so that is one objective is that yes, you are sensing that your motor is on and off. That is through IoT that you are doing, right? But to send the data, right? The node should be alive, right now, because if your battery gone, right, your node is gone, right? So then that motor is totally disconnected from the IoT networks. Got it? My point. Okay, so that result or that slide that I've shown with the respective of this sustainable sensor node. Okay.
And sir, for all the sensor node, you are using Raspberry Pi.
Yeah. Yes. So for if I'm bringing my some deep learning model, I'm using Raspberry Pi. Right. If you are sending only for data collections, then I'm using normal ESP.
Sir, in one slide you saw there is 4 Raspberry Pis. So if we are deploying the sensors and with the Raspberry Pi, then how many Raspberry Pis we need to fill like 2-3 acres of agricultural field?
Yes, so that depends at respective node how much coverage is able to do it.
Like
So
sir,
because
your
see, yeah, I
capacity
understand. Yes, I understand.
users are there used. Now, sir, the like the crop. If we go with the cotton crop and the rice crop or the dal, so they are having different moisture level. For like the rice crop, it always need the moisture level should be at the root of the of the crop. And if we go for the cotton, it should be ground. It means around 1 meter the moisture level. So how you
Right.
are finding the moisture level of the crop? Are you putting those sensors in how much inside the soil?
Uh, yes, so for that we actually have developed a soil moisture sensor which can go for the see that what you're telling for the rice crop it is nothing but the topsoil soil moisture content, right? And for the cotton it's a deep soil, right? Or deep rooted. So it is coming that it should go the deep. Okay, so maybe 30 centimeter, for example, if I consider, like, and another case is in the topsoil. So yes, soil moisture sensor is again we have a different version, two version. We will one for the topsoil or one for the your deep soil. So whatever the moisture sensor that we have developed, so it has the both the functionality. Better requirement, you have to change that probe that we have developed.
Okay, so we have to put that sensor inside the ground while deploying
Yeah.
those.
Yes. That depends that you have to select. That's the point. That which case yes applying, whether it's in rice or whether it's a cotton.
Sir, actually, my doubt is like in the if you know in Maharashtra during summer up to April they grow cotton. Then after they go for the dark. Now the moisture sensor, how many times they will remove that sensor and they put it again?
Uh, that is again a challenging thing, right? Now, so that's I'm pointing out, right? Because if you one time installing, right? Because see installation or this infrastructure development is crop specific, isn't it?
Yeah.
So we using same infrastructure, whether you can solve or you can address the multiple crop or not, that again we have to look into. Okay.
They do it because a farmer cannot leave the ground as it is.
Right. I understand. Okay. Understand your concern. Okay. And actually that is a reason. So now people are working not only the soil inserted soil moisture sensor, now drone based the soil moisture capturing. Okay. So which is much more independent of that. People are working on that. The drone, that image that you captured, right? From this you mapped what is your soil moisture concentration. Not the crop, I'm telling.
If we go with the image, now, sir, if it is an optical image, it is only tell us about the.
No. Normal, I'm not talking normal RGB image, hyperspectral image.
So, sir, that is related to our satellites. Now, the satellites
No, satellite image is a the using of the satellite image is very difficult na, from farmer point of view. There is coming that's the reason I'm telling the drone UAV. They're connecting the multispectral camera and then from there they're mapping. Because you don't require that level of data from the marginal farmer point of view.
Yes, sir, but those data are freely available. That the hyperspectral data that you are saying, SAR data, which can all weather data, and that is not optical because Sentinel-1 is providing us the data set which can go inside. That is also providing us the moisture level, sir. That is not optical.
Yes, that's the point I'm telling. Yes, it is theirs. Okay, but now also it is coming with the drone. Okay, with using drone technology, people are working. Okay.
Sir, one more thing. Sir,
Yes.
you also thought that the crop leaf like chlorophyll monitoring, like the
Chlorophyll.
leaves. Chlorophyll. Now, sir, what sensor you are using for that?
That I have used a color sensors.
So sir, that is going on with NVDI or something like it is providing the.
Yes, that we have means calibrated with a spectro. Okay, means a spectrophotometers and means speedometer is here right now. So still from this, okay. So we are in parallel of that we are developing that.
So it is providing the near infrared wavelength.
No, actually we have taken RGB, okay, and with some other optical filters, okay, nearly 800 nanometer optical filter we have used, okay, and on top of these RGB sensors, and from this you have calibrated.
So are you comparing that with the data sets or the real speedometer data?
Real spectrophotometer. With that we are comparing, which we are calibrating. Okay, means what is the process? You can take the leaf, right? From there you can extract the through chemical process you can extract the chlorophyll part, and then using a spectro you can check on your sample what is the chlorophyll level, right? And then on the same leaf we did for this through our developed sensors, we got the result, and from this we are doing the calibrations.
Sir, this chlorophyll actually reflect the green and near infrared lights because it is that's why we use filter out the red and
Yes, the filters, and there is a image processing techniques is involved there. Okay, the right channels you have to select, and then from there it is. So I didn't show in detail because that work is under review. That's why the detailed result I didn't produce there.
So in crop monitoring is also you are going with the image only. Means if you saw a image of a leaf which is affected by some disease, that is also image analysis.
So that we did using a smartphone finally. It has a two version with a Raspberry Pi and camera. Okay, so which is attached in our the IoT Kishi node that I have shown. Okay, so that is placed. So it is like a surveillance camera. Okay, it is monitoring with a time interval. And for that is little bit big farmer application point of view and small farmer application point of view, it is a smartphone. Just take an image and there itself we will get the result without any network dependency.
So you are also working with this edge computing?
Yeah, we are bringing the model to the smartphone means it is edge computing, right? We are bringing the model to the Raspberry Pi means it is edge computing.
Sir, then you are also working for blockchain and all this are connected
No,
together.
I'm telling in our group, what we are working, blockchains we have introduced. Suppose, as I mentioned, we are monitoring the soil health, right? Right. The fertilizer, right? What is the right quality of the fertilizers that you have added? As a organic fertilizer, people are claiming, right? So it required from the customer point of view. Second is also required, as I mentioned, the government gives a subsidy on the usage of the fertilizer. Right, so there should be a proper traceability and the transparency should be there. Okay.
Okay, sir. Thank you, sir. Thank you very much.
Yeah, thank you.
So while taking the images, is there any direction or the size of the images, all that matters to that model, deep learning model?
Yes, yes, yes. Okay, because see, that depends again on what you're doing. If you're doing any kind of dimensional analysis, if anything is involved, right? So then your distance or the size is matters,
So
right? Because see,
the farmer
yeah,
will be
so
asking,
how it will be done, because see, one of the example I've shown the internet of leaf things that we have proposed. Okay, that was the solution that we have developed. So where we are monitoring the leaf, right, and based on that we are doing the dimension analysis of the leaf. Okay, so now just try to understand. Okay, suppose you are using a smartphone, you are taking someone or some uh, suppose water bottle pictures, right? If you go nearby you'll find the dimension is bigger, and if you go far away dimension is less. So that means ultimately depends that what is the gap between your camera and your target, that you need to fix it. Okay, this is one thing. Second things, in many cases what we're doing, if there is a smartphone applications, we suppose a rice leaf. Okay, so you know what is a typical dimension of a rice leaf. We're making a template, just like template of that. You try to means farmer point of view, what they or farmer have to do, that you fit your image within the template. Just for example, you might have seen lens card, right? What will be your frame size, right? So they have a some your own, you put your own image, then they put a on template of your eyes and the face, right? So then you try to fit it. Okay, so similar concept we did. Okay, so that based on the requirement what our model requires, farmer no need to do too much adjustment, just try to fit your image within that, and then model will take care.
image size, does it matter the camera quality and the pixels, number of pixels?
No, see the size matters, right? Because what is the model you're, suppose which deep learning model you're using, right? So every deep learning model will having its own input size, right? No. Okay, so you have to do the pre-processing part there. Okay, so so that is the reason we made the template, right? You fix, okay, whatever the whether you are using tablet or your any low configured smartphone, right? So the image definition should come on the with the same reference.
So through the template, the size will be in that range. Whatever the
Yes, yes.
camera.
Yes, means as three, 4, 5 different version like Redmi, OnePlus, Samsung. Okay, we have tested and we have generalized that.
Any other question?
Hello, sir.
Good morning, sir.
Yes, hello.
Good
Yeah.
morning, sir.
Yes, good morning.
Sir, one of your slide you showed the IoT Krishi network where many sensors are deployed in the field. So actually, I wanted to know that which data collection technique you are using, like all the sensor data transmitted to the sync directly, or there is any clustering technique. Like one hop cluster or multi hop cluster, like that.
Okay, okay. So is that we made a mesh networks? Okay, mainly yes.
Okay. Okay.
Right. So that is a mesh network that we have developed because we have to
Okay.
cover more area, right? Now
Okay.
this is one thing, and also see the field. Also, many times the field also will find they divided the zone wise, right?
Okay,
Zone
sir.
1, zone 2. Basically, if it is a large field,
Mm-hmm.
generally they divide in the zone wise. Right? So
Okay.
that's why we made is a mesh network.
Okay. So the sync, the position of sync is means at the center or somewhere at the corner, or where actually?
Currently, we did at the corner.
Okay.
Okay.
If the sink is at one corner, but if a sensor is at the another corner, then I think the energy consumption to transmit the data will be more.
Yes, that is again that is the trade-off, right? That is a
Okay.
trade-off that we have to do, right? And actually, on that context, if you see the what now people are looking for, um, dynamic allocation of your node means the header node. Okay,
Okay.
means now I am talking at the static header node. Okay, but now it is people are more talking about the that you're telling the clustering, right? So
Yes, sir.
dynamic cluster formations. Okay, so
Okay.
you may know in if you work in the network point of view, know that now people are talking about the virtual networks, right? Now,
Okay.
or that software defined networks, right? So
Yes.
there,
Yes.
this dynamic thing is coming. Okay, so that is
O-
another research domain. Okay, if you want, you
Okay.
can look into.
Okay. Okay, sir. Thank you, sir.
Hello, sir.
Hello.
Sir, in smart agriculture, using a IoT applications, this is an approach for crop. If we use a crop with a in field of cryptography, regarding the novel approach of any random crop, random number crop, to know how is the efficiency, increased efficiency in terms of different parameters, area, power consumption, efficiency, as well as how is the stochastic model will be feasible. We applied for particular true or pseudo random particular crop random number will be applied in a
No, your first point I didn't understand. What is the first sentence you told?
yeah. I'm
You can
asking
repeat.
that yeah, any true or pseudo random number of crop. If you take a this randomness calculations using this crop procedures model is a stochastic model will be used for IoT applications is a feasible model if we applied for any energy consumptions or entropy and area technique area calculations. So this literature AIoT agriculture literature will be used for AIS 31 cryptography model TRNG core model. We
Um,
using this that
Truly speaking, that part I have to look into is what exactly you're talking. Okay. But in
any
general, what I can
particular
say, yes, sir. See the energy, because when you're talking about the IoT networks, right? If I'm telling in general IoT networks point of view, so it can be agriculture or any application. So the energy is a concern, right? So now energy optimization is how we can do, right?
yeah I am
So
also a cryptography is a use this calculated this a smart agriculture procedure AIoT application
Okay,
model.
okay. Cryptography part, I didn't means I didn't explore too much. Maybe I'll not be the good person to guide you towards that. Okay.
Sir, what parameter of evaluations using this AIoT smart model, suggestive model?
That's something cryptography part. Maybe I'm not the good person to answer because that is not my expertise area.
Yeah. For secure transmission, this is will be calculated in
Yes,
terms of
secure transmission point of view. It is yes, you can use it. Okay, may see. That's why we mentioned yes, you are handling means when you're sending the data, right? So that times we do the small security protocols we apply it. Okay, but it requires, right? See, suppose if it is a healthcare, okay, or any financial data, so then what is the level of security or the required, right? But agriculture data is might not require that much security, right? So why I'm telling, see, at the end, the solution I'm doing for the home for farmers, right? So we should not technologically, we should not burden. Okay, so we can use it. Okay, but thing is, really is it required? Really, how much I am benefiting? Okay, that also you have to parallelly look into. Okay, so please think that point. Okay, because
randomness of any crop we calculated this model.
randomness means I didn't understand that. Means
Any agriculture crop will has something type of randomness in terms of applications, higher yielding procedures, quality procedures, efficiency, entropy. There are so much
okay,
parameters.
okay, maybe I have to look into that. Okay.
So, one second. So, sir, I will just add one line to, I think Pratik was asking one question. He's actually basically a security guy. He is very much active from the day one of online to offline till now. So he is asking like what I know. Sir is using ESP32 or Node MCU for data collection, he told, and Raspberry Pi for edge node computing and all, or some sort of that. So what I remember is ESP32 has a random number generation IP core inside it, or a block, RSA and AES, and some other thing related to cryptography. So Pratik, I suggest see it is good that you can design all these things in Verilog or RTL and go for doing parameterization. But that is always again to decide like whether you are doing low power or some particular ASIC based solution. In that it is fine. But when SAR is doing in implementation level where end user is a farmer who is nothing to do with security or something like that, end user, okay, so or very less to do with security. So at that time the designer can use these on chip peripherals like RSA, AES, random number generation, like company has thought that this is required, so we'll put it as a peripheral, crypto peripherals, and that has to be initialized and we can use it for our application. But no doubt we cannot just parameterize all these things because it is already parameterized and fabricated in IC. So only to use it for our application because we need rapid prototyping. If we are not doing and investing time or by doing all these things, then we'll lose the market or somebody will publish in the paper. So we cannot publish, we cannot do the patent. So that is just my view. I hope you got something. Okay, so right,
Sir,
means one part and
hello, sir. Sir, I am asking to the seed generation. Seed generation procedure will be the in the smart agriculture for seed generation. Seed generation procedure it will also be done in terms of IoT in smart agriculture crops. So So seed generation procedure is same like as a random number generation in a smart agriculture procedure. In terms of same procedure will be applied here, such as security in a IoT smart agriculture procedure. It's same procedure here applied for seed generation procedure, it also in crop in IoT.
Sir, is this anything about seed generation is telling? But Pratik, is there any relation between seed generation with security?
Yeah. See any pseudo or true random number model, stochastic model for implementation.
No, seed or pseudo. I am also confused. But anyway, ESP32 has a very good like AES, RSA, even if random number generation peripheral on it. You can initialize and use. Okay, Pratik, we'll discuss or we'll take it offline also if you want. Sir may have other engagement. We just sir up to 11:30 now. It is almost 12. So okay, sir. Thank you for coming.
Yeah,
Okay,
thank you for nice interaction also. Right.
We just thought to like we are somehow some place somewhere we all are connected. So we got a chance this time to be again connected through our hosts and participants. Thank you, sir, and we'll talk sometime. And
Sure.
thank you, sir. Thank you.
Thank you.
Sir, we will just all recorded session we have done. We need to upload also in ICT. They have told. So we are just seeking your advice on it because we have to upload on ICT also. Like
This recording?
Yeah. For all the sessions, we'll go to Atal IIT.Rourkela logo and we will give it in Google Drive of them. What they will do, that is their this. But they will do
That is fine.
That we have. Thank you, sir. Thank you for coming and giving.
Right. Thank you.
Okay. Thank you, sir. You may leave now. Thank you. Okay, for participants, what I am telling is to we are end today, almost we are towards the end of this session. And today now we have an industry interaction report. So what I suggest is any of you will or all of you or any of you may do volunteer for creating a report and that will also give to attach with our final report of this project. Okay, and